Yeah, hi there. This is a quick tutorial on NumPy. So what is a NumPy? NumPy it's a Python package. Stands NumPy, the word stands for numerical Python. It is a core library for scientific computing. So how do we install NumPy? Using pip install and name of the package, that is NumPy. Using we can install it. Once it is installed, we can load it using import NumPy as NP. Now, if I want to check the version of the NumPy, we can see np dot underscore underscore version underscore underscore, that is dunder version. We get the version of the NumPy. I'm using NumPy of version 1.18.1. So in NumPy, the basic object that we deal with is the array, which is an n-dimensional array called as nd array, which is usually of fixed size, and it contains the items or the elements of the same data type and the same size. So how do we create an array? So what I'm doing is I'm just creating a one-dimensional array here. So this basically is the runs is scored by a batsman in a 5 matches one-day series. So these are the runs he scored in the 5 matches in a one-day series. So 110, 18, 50, 20, 140. I'm capturing these runs scored by him in an array, NumPy array, which is runs. Now, once it is data is stored, if I want to check the data type of the object, we can use function type. So I can say type and name of the object, which is runs. I get as numpy.nd array. So it means this object is a numpy array. Now, since array it's n dimension, so the next thing that we can check is how many dimensions this array is having. So we can check it using uh, object name dot ndim, which gives the number of dimensions. Since it is a one-dimensional array, so we get ndim as one, that is it is one-dimensional array. And next is how do you check the shape? So by shape it means we we want to find out the number of elements in each dimension. So we can get it using object name dot shape, that is array numpy array dot shape. So here we have runs dot shape. So we get 5 comma nothing. So what it means, it's a one-dimensional array, and that one-dimensional array has 5 elements. If I want to find out the total number of elements in the array, then we can do uh, array dot size. So there are 5 elements in the array. So that's a quick way to create any one-dimensional array and check some basic properties like what is the dimension, the number of elements in the dimension. Now, now I'm going to perform some basic functions on this one-dimensional array. Let's say if I want to find out what was the total number of runs scored by player in that series, so we can use the function np.sum, and we can pass the array to it. So we get the output as say 400. So it means the player scored 400 runs, total 400 runs in that one-day series. Now, the same thing if you want to find out using another function which is called as cumulative sum. So it's like adding one value with its previous value. So it starts from 110, then the next innings he scored 80. So 110 plus 80, 190 plus 50 is 240. Like this way it will keep on adding, and in the end you get the total sum. So it's like cumulative sum that we do. So np dot cum sum, which is cumulative sum, and array name, which is runs, and we get the output. Now let's see if I want to find out what was the minimum score, maximum score, and what was his average score in the series. So we can find out using np.min, np.max, and np.mean, and I'm passing the array to each of these functions. So what I'm creating is a dictionary where key is min score, max score, and series average, and the value is its corresponding numpy function. So we get the minimum score is 20, maximum he scored 140 in the series, and the series average was 80 runs. Okay, now let's moving further. Now we are creating a two-dimensional array. So let's say for the same player, I'm capturing the number of runs he scored in a 5 matches test series. So as we know, in a test match there are 2 innings. So he played in both the innings of each of the test matches, and this is what he scored. So this particular list represents the runs he made in the first innings, and this is the second inning. Similarly, this score represents for the second test match, So 90 he made in the second test match first innings, 100 he made in second test match second innings, and this way. So each row represents a test match, and each column represents the innings of that test match. So this is the first innings, and this is the second innings, this is the first test match, second test match, third, fourth, fifth. Now one thing to notice, in Python, indexing starts from 0. So whenever we are going to index and to find out a specific element, we should, we have to start index counting from 0, because indexing starts from 0 in Python. We'll cover it a bit later. So let's first cover the basics. Since this is a NumPy array, so we want to find out what are the dimensions of it using ndim. So number of dimensions are 2. So as we see, there are 2 dimensions. In a way, we can think it like rows and columns. So there is row is 1 dimension and column is another dimension. Now, what is the number of elements in each dimension? So we can get it using shape. So test underscore runs dot shape, we get 5 comma 2. So there are 5 rows and 2 columns. So in a way, in the first dimension, so this is the first dimension, which is row, there are 5 rows. So there is 1 2 3 4 5, and each dimension there are further 2 data points. So in each row there are 2 columns. So there are 2 columns. So another thing to notice, the dimension is also called as axis. So, and as you know, indexing starts from 0. So axis 0 means this is along the rows, and axis 1 means along the columns. So to keep it simple, how many, if from the output we get, from the output of the shape we get 5 comma 2, that is there are 5 rows and 2 columns. So 5 rows and there are 2 columns, first column and second column, just to keep it simple. Now again, to find out the total number of elements in the array, we can say array dot size. So there are 10 elements. So 5 into 2, 10. Now, now let's come to the memory part. Now each data item or each element of the array will occupy some space in the memory. If I want to find out what is the number of bytes occupied by each element, we can do it like this. We can array name dot item size. So this gives the length of an array element in bytes. That is, each element occupies 4 bytes. Okay, and how many elements we have? We have 10 elements. So totally there will be 40 bytes occupied by this array. So if I want to find out the total number of bytes occupied by all the elements of the array, we can do it like this: array dot n bytes, so which is 40. That is number of elements, which is 10. Each element taking 4 bytes, so it is 40 bytes. Okay, let's print this array again. Now there are some functions we want to run on this two-dimensional array. So now first thing I want to find out what was the total number of runs he scored in the test series. So that is sum of all the innings basically. So it's simple, array dot sum. This will give the sum of all the elements of the array. So 888. So we scored 888 runs in that series. Fine. Now I want to find out match wise how many he scored in each match. So that is, this is the first match. So he scored 80 and 88. So that is, he scored 168 in the first match. In the second match, he scored 190. Third match, he scored 60. So like this way, I want to find out. Now, so basically, what we are doing is we want to find out the sum along these columns. So I want to, what I mean is I want to add column 1 and column 2, and I want to find out the sum. So adding column 1 and column 2, this will give me the total runs scored in innings, first innings and second innings for each match. So along the column means x is equals to 1. If you go along the rows, that is, when I say along the rows means like this, along the rows, that is, x is 0. Along the columns means along the columns, x is equals to 1. Okay, so in this case, we want to sum the columns. So we have to sum the columns. So we want to sum along the columns. That is, we give x is equals to 1, and then we get the number of runs he scored in each match. So 168, 190, 68, 180, 290. Now I want to find out what was his average score of the first innings versus second innings. Basically, I want to compare how he performed in the first innings versus second innings in that particular series, whether he was good in the first innings or he was good in the second innings, just like a comparison between these two innings. So what we want to find out, the average. Now this time we want to find out average of, so first one average I want to find out along these rows for the first innings, and second average, and the second thing I want to find out average along these rows to get the average of the second innings. So this is along the rows for the first innings and along the rows for the second innings. So how do we do this? We say test underscore run dot mean. Mean is to get the average, and x is equals to 0. So x is equals to 0 means along the rows. So it will find out the average along the rows. This. So we get average is 98 for the first innings, and similarly for the second innings for all these rows we get average around 79.6. So it means his average was more in the first innings compared to the second innings. Now comes the part which is indexing. So let's again print the array which is test underscore runs. Now we have to do the indexing. Let's say, now before going that, indexing, as I said, in Python indexing starts from 0. So this is a two-dimensional array, so it means there are two dimensions, so there are two axes. Okay, and in each axis we have number of elements, so two. So it means we have indexing starting from 0 in each of the axes. So let's say if I want to find out the runs scored by player in the second test match. So second test match is this one. This is the second test match. Now, what is the index of this? Because index starts from 0, so this is index 0. So this test match is of index 0, and this test match is of index 1. So I want to find out the runs scored by him in the second test match, that is of index 1. So what I'll do is test underscore runs, square bracket start, then the row index is 1, and comma, and after that if there is any specific column index, then we can give that column index. And if I want to see all the elements of that row index, I want to see all the elements of the basically row, that is all the elements of the columns, I can give colon. So colon means give all the elements. So what it will do, it will go at the index 1, that is on the row index, it will go at index 1, so row 0 row, first row, and give all the elements of that index, that is all the elements which are in the column. So that is why we have colon here, because there is nothing specific I want everything from the columns of this particular row. So test underscore runs 1 comma colon will give me 90 comma 100. Now let's take another example where I want to see the runs scored by player in the second innings of fourth and fifth test match. So first, what is the fourth and fifth test match? This is the fourth test match and this is the fifth test match, because indexing starts from 0. So index of this is 0, 1, 2, 3, and index of this is 4. So for index 3 and 4, I want to see the runs scored by player in the second innings. So row index is 3 and 4, and the column index is, because I want to see the second innings, so column index is 0, 1. So this is the column index, uh, this one and this one. This column belongs to index 1, this is index 0 for the column, this is index 1 for the column. So on the row side we have index 3 comma 4, and on the column side we have index 1. So this is what I'm giving, test underscore rows, first the row index which is 3 comma 4, because there are two values, so I'm specifying it in the list itself, comma, and then the column index which is 1. So I'll get 100 comma 90. So 100 comma 90 is scored in the second innings of third and the fourth and the fifth test match. Now, we can also give negative values in the indexing. What it means is, whenever we give negative values in the indexing, it means the axis starts from the back, that is from the last element. So let's say if my question is what was the runs scored by player in the last innings of a series. So let's say you don't know how many rows are there and how many columns are there, and I want to see the last element. So it means on the row side I want to go at the last row, and on the column side I want to go at the last column. Since negative index starts from the last. So from on the row side we give -1, and on the column side I give -1. So I'll reach here. So test underscore runs -1 and -1. Now let's say I want to answer a couple of more questions. I want to see in which innings he was more consistent. That is, I want to see the standard deviation of the first innings compared to it with the standard deviation of the second innings. So what we have is now I want to see all the rows belonging to the first innings. So that is all the scores of the first innings. So how do we get it? Test underscore runs, then square bracket start. Now since I want all the elements from the rows, so I give colon here, comma and 0. 0 is the first column. So 0 is the index of the first column, that is the first innings. So it will give me all the scores made in the first innings, and using .std I'll get the standard deviation. Similarly, I want to find out for all the matches second innings and the standard deviation. So test underscore runs, this colon represents all the rows, that is all the matches, comma 1 means the second innings, that is the innings at index 1, and I'll get the standard deviation using .std. So for the first innings I get standard deviation as 53, for the second innings I get standard deviation as 30. So it means in the second innings the player was more consistent as the standard deviation is low, where in the first innings he was not that much consistent. Now some Boolean conditions we can specify. Let's say I want to find out how many centuries player scored in that test series. So if I simply just give this condition, test underscore runs greater than equals to 100, that is he scored at least 100 runs, then in the output we get of the in the output we get an array which is having the values as true or false. So wherever this condition holds true, we will get true, and wherever the condition holds false, we get false for that particular index. Okay. So in the output we get an array which is of the same dimension as the original array, and its values are true and false depending upon whether this condition holds true or not corresponding to that particular element. So if you see false, 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 true, so it means this is true. So it means the player scored 100 or 100 plus in this innings. Similarly, this is true and this is true. Now I want to find out the count of number of centuries. So what we have to do is simply just sum it up. So basically in Python, any false value is represented as 0, and any non-zero value is represented as true. So in this case, true is represented as 1 and false is represented as 0. So if I just sum it up, then I'll get this, since true is 1, so I'll whatever truths are there, they will be represented as 1, and if I count it, I'll get the if I sum it up, I get the number of count of the centuries. So what I'm doing is np.sum, and this Boolean condition test underscore runs greater than equals to 100. So this gives me 3. So he scored 3 centuries. Now I want to find out how many centuries he scored in the first innings versus the second innings. So again, I have to access all the elements of the first innings, check this condition, and sum it up. So how do we do this? So first is I have to access all the elements of that is all the runs he made in the first innings. So how do we do this? Test underscore runs bracket start colon means all the matches, and comma, and after that 0. 0 means runs in the first innings, and this is the condition that this is greater than equals to 100. This is the condition. It will return in the form of true or false. So and I want to sum it up so that I get the uh, total sum. So this returns 1. It means in the first innings he scored only 1 century. Similarly, for the second innings we can get test underscore runs colon representing all the rows, that is all the matches, comma, and the second innings is at index 1, so that is 1 is coming, and after that I'm putting a condition greater than equals to 100. So wherever is scored at least 100 runs in the second innings, it will find out in the form of true or false, and I'm just summing it up to get the total sum, which says 2. So it means he scored 2 centuries in the second innings. Okay. Okay, now let's display the array again. Now I want to find out in which innings he scored the maximum runs. Okay, So there is a function called as argmax. So the way we specify is array name test underscore runs dot argmax, and x is equals to 0. That is along each row, it will check and it will give us the maximum. So maximum I get is 4 comma 1. That is uh, index 4 comma 1. So index 4 is 0 1 2 3 4. This is the index 4, and this is the first element we have. Now if I want to find out the information about array, we can get more information using np.info and name of the array. So we'll get a lot of information like what is the shape, what is the item size, 4 bytes, shape is 5 comma 2, class is nd array, item aligned is true, in memory it is contiguous is true, and the type of each element is int 32. So this gives more information about a particular array. So basically in this tutorial we covered like how to create an array, one dimensional array, two dimensional array, how to access individual elements of the array using the indexing. Then we can apply some functions on the array elements, either on the whole array or on specific axis. Okay, so this is what we usually do in our day-to-day work when we're dealing with the NumPy. We create an array, usually two-dimensional array, and then we apply functions on it. So that's a quick introduction and to a NumPy array. Hopefully it is helpful. Thank you.